Hello, in this lecture we'll find out the radius of the semicircle. In the drawing we have a semicircle. PA is tangent, line segment PA is tangent to the semicircle at point A, and you know that the length of line segment PA is 6 units. Line segment PQ equals to 4 units in its length. And we also know that line segment PS cuts the semicircle at points Q and S. We also know that QS equals to QC. This angle PAB equals to 90 degrees in its size, and this is angle SQC that is also equals to 90 degrees in its size. Our mission is to find out the radius of this semicircle. So first of all, I will present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 10. According to rule number 10, in any circle, if AB is any chord in the circle and PT is a tangent to the circle, then the following equation is true, that PT square equals to PA times PB. So in the drawing we have tangent PT that is tangent to this circle at point T, and we have line segment PB that cuts the circle at points A and B. AB is a chord inside the circle, and according to this rule number 10, the following equation is true, that PT square equals to PA times PB. Actually, we can implement rule number 10 in our drawing. Why? Because if we focus at point P, in our drawing, from point P, we have tangent PA to the semicircle that is tangent to the semicircle at point A, and we have line segment PS that cuts the semicircle at points Q and S. Therefore, we can implement rule number 10. According to rule number 10, we get here that PA square equals to PQ times PS. Repeat again. According to rule number 10, if we focus on point P, in the drawing, we get that PA square equals to PQ times PS. PA is 6, therefore PA square is 6 squared, that is 36, and it is equals to PQ is 4 times PS. PS in total equals to 4 plus QS. So if we found out that according to rule number 10, 36 equals to 4 times 4 plus QS. Here we'll divide this equation by 4. And finally we get that 36 over 4 is 9. And 9 equals to 4 plus QS. Here we subtract 4 from this equation, and finally we get that QS equals to 4, 9 minus 4, that is 5. So QS equals to 5 units in its length. Line segment QS equals to 5 units in its length. But it is given as the question that QS equals to QC, and QS is 5, therefore QC must be also equal to 5 units in its length. In the next step, we will join points P and C together by a straight line. And we'll focus on the lower side of the straight line PS at point Q. At the lower side of PS at point Q, the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. I'll repeat again on rule number 3. according to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. We have the straight line AB. If you focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of AB at point Q? We have this angle that is alpha plus beta. So according to this rule number 3, alpha plus beta must be equal to 180 degrees. So we can actually implement rule number 3 in our drawing. Right? Because in our drawing, if you focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees. Plus the missing angle, in total they must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles at the lower side of the straight line PS at point Q to 180 degrees, the missing angle here must be equal to 90 degrees. Therefore, triangle PQC is a right triangle. So, we will copy the right triangle PQC in the new page, and we will implement the Pythagoras theorem on this right triangle, triangle PQC. PQ equals to 4 units and QC equals to 5 units in its length. So this is the right triangle PQC that they copied from the original drawing. Here by PT is the version for Pythagoras theorem. In this right triangle PQC according to the Pythagoras theorem, we get that PC squared equals to PQ squared plus QC squared. So PC squared, that is the square of the hypotenuse, equals to PQ squared. PQ is 4, therefore PQ squared is 4 squared, that is 16, plus QC squared. QC is 5, therefore QC squared is 5 squared, that is 25. So in total we found out that PC squared equals to 16 plus 25, that is 41. So we actually found out that PC squared equals to 41. PC squared equals to 41. In the next step, I will copy the right triangle PAC in the new page, and we will implement on this right triangle PAC the Pythagoras theorem. Here we define the length of side AC as A. We already found out that PC squared equals to 41 units. So write it down. So actually, this is the right triangle PAC that I copied from the original drawing. My PT is a version for Pythagoras theorem. So in the right triangle, triangle PAC, according to the Pythagoras theorem, we get that PC square equals to PA square plus AC square. PC square is 41, so 41 equals to PA square. PA is 6, therefore PA square is 6 squared, that is 36, plus AC square. AC is 8 according to our definition, therefore AC square is A squared. So in conclusion, we found out that 41 equals to 36 plus A squared. Here we subtract 36 from this equation, and you get that 41 minus 36 is 5 equals to A squared. Here we take a root out of this equation, and finally we found out that A equals to the square root of 5 units. A equals to the square root of 5 units, so we can write here that A equals to the square root of 5 units. So we know that this is a semicircle, therefore AB is the diameter of the semicircle. I'll write it down here. AB is the diameter of the semicircle. We define the radius of this semicircle as R. We define the radius as X. We define the radius of the semicircle as X. Therefore, the diameter AB must be equal to 2x. So AB equals to 2x. AB equals to 2x. It is the diameter of the semicircle. So AB minus AC equals to CB. I repeat again, AB minus AC equals to CB. So I'll write it down. CB equals to AB minus AC. Repeat again, CB equals to AB minus AC. So CB equals to AB, that is 2x, minus AC. AC is A, and A equals to the square root of 5. So AC is square root of 5. So in total, we found out that CB equals to 2x minus square root of 5 units. So I write it down in the original drawing that CB equals to 2x minus square root of 5 units. Okay, so in the next step, I'll complete the semicircle to a circle. So I completed the semicircle to a circle, and we will extend side QC until it touches the circle. We define the touching point of the extended side QC with this circle as point M. In the next step, I will present to you a new rule, and we implement the new rule in our drawing. The new rule is rule number 11. According to rule number 11, in any circle, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times BO equals to CO times ZO. So here we have two chords that intersect with each other. that is to say chord AB intersects with chord DC at point O. Therefore, whenever you have two chords that intersect with each other, then the following equation will be true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. Okay, so I can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. I'll repeat again. Chord AB intersects with chord QM at point C. So whenever you have two chords that intersect with each other, you can implement rule number 11. Therefore, you can implement rule number 11 in our drawing. So according to rule number 11, I'll repeat again. In our original drawing, we have chord AB intersects with chord QM at point C. Point C is the intersection point. Therefore, according to rule number 11, we get that AC times CB equals to QC times CM. QC times CM. We'll define the length of side CM as B. Repeat again, according to rule number 11, in our original drawing, AC times CB equals to QC times CM. AC is equal to 5 times CB, that is 2x minus square root of 5, and it is equals to QC. QC is 5 times CM, that is B. The conclusion is found out that according to rule number 11, in our original drawing, square root of 5 times 2x minus square root of 5 equals to 5b. Here we'll divide this equation by square root of 5. Equation number 1, we'll divide this equation number 1 by square root of 5. And we'll get that according to this equation number 1, 2x minus square root of 5 equals to 5b over square root of 5. Here we'll add square root of 5 to this equation number 1, and we get that according to equation number 1, 2x equals to 5b over square root of 5 plus square root of 5. So here we will multiply square root of 5 by square root of 5, and then we will divide it by square root of 5 in order to have a common factor with this expression. And finally we will get that according to equation number 1, 2x equals to 5b over square root of 5. So we multiply square root of 5 by square root of 5, and then we divide it by square root of 5, and finally we get that according to equation number 1, x equals to 5b plus square root of 5 times square root of 5 over square root of 5. That is to say, according to equation number 1, we actually found out. Here we divide this equation by 2, and we get that according to equation number 1, x equals to 5b plus square root of 5 times square root of 5 is 5 over 2 times square root of 5. Okay, so actually succeeded to find out the value of x, that is the radius of the semicircle, in terms of B. Okay. So in the next step, we'll join points M and S together by straight line. So inside the circle, we have peripheral angle MQS that is equal to 90 degrees. And because of the fact that this peripheral angle MQS is equal to 90 degrees, it must rest on the diameter of the circle. That is to say, MS is the diameter of the circle. I repeat again on rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have in the drawing peripheral angle MAN that is equal to 90 degrees, therefore this peripheral angle must rest on the diameter of the circle. That is to say, MN is the diameter of the circle. Okay. So we actually can implement rule number 5 in our drawing. Why? Because according to rule number 5, first of all we know that peripheral angle MQS equals to 90 degrees. This peripheral angle MQS equals to 90 degrees. And therefore, according to rule number 5, this peripheral angle MQS must rest on the diameter of the circle. That is to say, MS is the diameter of the circle. MS is the diameter of the circle. So if MS is the diameter of the circle and the radius of the semicircle is X, it means that the diameter must be equal to 2x. Okay, so then that is to say MS equals to 2x. The diameter MS of this circle equals to 2s. In the next step, I will copy the right angle SQM in the new page and we will implement the Pythagoras theorem of this right angle, triangle SQM. QM equals in total to 5 plus B. Okay. QS equals to 5 units. And the diameter MS, actually the hypotenuse MS is the diameter of the circle, that is to say it is equals to 2x. So actually this is the right triangle QSM that are coming from the original domain. By PT is a equation from Pythagoras theorem. This will be equation number 2. So according to equation number 2, in this right triangle QSM, MS squared equals to QS squared plus QM squared. MS is 2x, therefore MS squared is 2x squared. And it must be equal to QS squared. QS is 5, therefore QS squared is 5 squared, it is 25. Plus QM squared. QM is 5 plus B, therefore QM squared is 5 plus B squared. This is according to equation number 2. But according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. Therefore, we substitute x in this equation, equation number 1, by 5b plus 5 over 2 times square root of 5. We will do it now, we get that according to equation number 2, 2 times x squared. So it is 2 times x, and x according to equation number 1 equals to 5b plus 5 over 2 times square root of 5. So it is 2x squared that is equal to 25 plus 5 plus b squared. So here we have 2 in the numerator and 2 in the denominator, so 2 get cancelled. So in this side of the equation number 2 we have 5b plus 5 squared over square root of 5 squared is 5. In the other side of the equation we have 25 plus 5 plus b squared equals to 5 squared, that is 25, plus b squared plus 2 times 5b is plus 10b. Here we will open the brackets on this side of equation number 2, and we get that according to equation number 2, 5b plus 5 squared equals to 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, and 10b times 5 is 50b. 50b equals to 25 plus 25 is 50, plus b squared plus 10b. Here we have to divide this side of the equation by 5. So in this side of the equation we have 25b squared over 5 is 5b squared, plus 25 over 5 is 5, plus 50b over 5 is 10b, that is equals to 10b plus b squared plus 50. So here we have 10b on both sides of the equation, so 10b will get cancelled. In this side of the equation, after we cancelled 10b, we left only with 5b squared plus 5, that is equals to 50. Here we subtract 5 from this equation, and we get that here we have 5b squared that is equals to 50 minus 5 is 45 plus b squared. Here we subtract b squared from this equation, equation number 1, and we get that according to this equation, equation number 1, 5b squared minus b squared is 4b squared, so 4b squared equals to 45. Here we divide this equation by 4, and finally we get that b squared equals to 45 over 4. Here we will substitute 45 by 9 times 5, and we get that What is the equation number 2? B squared equals to 9 times 5 over 4. Repeat again. Found out actually that B squared equals to 9 times 5 over 4. Here we take a root out of this equation, equation number 2, and we get that B equals to the square root of 9 times 5 over 4. So, according to equation number 2, B equals to the square root of 9 is 3 and the square root of 4 is 2. So inside the brackets we left only with 5. In conclusion further that according to equation number 2, B equals to 3 times square root of 5 over 2. Well, according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. In the next step, we substitute b in this equation, equation number 1, by 3 times square root of 5 over b. And you get that according to equation number 1, x equals to 5b. So it is 5 and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. So x equals to 5 times 3 is 15, so it is 15 times square root of 5 over 2. Here we multiply 5 by 2 and then we divide it by 2 in order to have a common factor of this expression. So it is 5 times 2, that is 10, divided by 2 over 2 times square root of 5. Here we move 2 times square root of 5 to the denominator and we get that x equals to x equals to 15 times square root of 5 plus 10 over 2 times 2 times square root of 5. So according to equation number 1, x equals to, here we take square root of 5 as a common factor from the numerator. So what is left from 15 times square root of 5, so we do from it square root of 5 as a common factor. What is left is actually 15 plus what is left from 10 after we took from it square root of 5 as a common factor. What is left is actually 2 times square root of 5. Why? Because 2 times square root of 5 times square root of 5 is 10. All divided by 2 times 2 is 4 times square root of 5. So here we have square root of 5 in the numerator and square root of 5 in the denominator, so square root of 5 will get cancelled. And finally we get that x equals to 15 plus 2 times square root of 5 over 4. In terms of numbers, it equals to 4.8680 units. And that is the answer to the question. The radius of the semicircle and also the radius of the circle equals to either 15 plus 2 times square root of 5 over 4 units. In terms of numbers, the radius of this semicircle is equals to 4.8680 680 units. Okay, so in the next step, I'll summarize the lecture. In this lecture, I found out the radius of this semicircle. In the drawing, we have a semicircle. PA equals to 6 units in its length, and PA is tangent to this semicircle at point A. We also know that PQ equals to 4 units in its length, and line segment PS cuts the semicircle at points Q and S. We also know that QC equals to QS, and this angle PAB equals to 90 degrees in its size, and this angle SQC equals to 90 degrees in its size. And again, our mission is to find out the radius of this semicircle. Okay, so the first step, I presented to you a new rule number 10, and we implemented rule number 10 in our drawing. According to rule number 10, in any circle, if AB is any chord in the circle and PT is a tangent to the circle, then the following equation is true, that PT square equals to PA times PB. Okay? We have here tangent PT is tangent to the circle at point T, and we have line segment PB that cuts the circle at points A and B. So AB is a chord inside the circle. So according to rule number 10, the following equation is true here, that PT square equals to PA times PB. We can actually implement rule number 10 in our drawing. Why? Because in our drawing we have from point P tangent PA to the circle, and we have line segment PS that cuts the circle at point Q and S. Therefore, we can implement here rule number 10. Okay, again, if you focus at point P, according to rule number 10, we get that PA square equals to PQ times PS. Again, according to rule number 10, PA square equals to PQ times PS. PA is 6, therefore PA square is 6 squared, that is 36. That is 36, and it is equals to PQ, that is 4, plus PS in total equals to 4 plus QS. Again, PS equals to 4 plus QS. So here we divided this equation by 4, and finally found out that 36 over 4 is 9, so 9 equals to 4 plus QS. Here we subtracted 4 from this equation, and finally found out that QS equals to 9 minus 4, that is 5. So here QS equals to 5 units, and because of the fact that QS equals to QC and QS equals to 5, therefore QC must be also equal to 5. Yeah. Here QS equals to 5, and therefore QS that is equal to QC, it means that QC must be also equal to 5 units. Then join points P and C together by a straight line, and we implemented the Pythagoras theorem on the right triangle PQC. Actually, here we have rule number 3. We know that PS is a straight line. If we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees. According to rule number 4, the sum of the angles on one side of a straight line is equal to 180 degrees. Here AB is a straight line, so if we focus on the upper side of the straight line AB at point Q, the sum of the angles here must be equal to 180 degrees. So which angles we have at the upper side of AB at point Q? We have angle alpha and angle beta. Therefore, according to this rule number 3, alpha plus beta must be equal to 180 degrees. We can implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on the lower side of the straight line PS at point Q, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the lower side of PS at point Q? We have this angle that is equal to 90 degrees plus the missing angle. In total, they must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees. Therefore, triangle PQC is a right triangle. Therefore, we implemented the Pythagoras theorem in this right triangle, triangle PQC. So we copied the right triangle PQC in the new page and we implemented the Pythagoras theorem in this right triangle, triangle PQC. This is actually the right triangle PQC that I copied from the original drawing. PQ equals to 4, QC equals to 5. The Pythagoras PC is missing here. So according to the Pythagoras theorem, in this right triangle PQC, PC square equals to PQ square plus QC square. So PC square equals to PQ square. PQ is 4, therefore PQ square is 4 squared, that is 16, plus QC square. QC is 5, therefore QC square is 5 squared, that is 25. So in total, PC square equals to 16 plus 25, that is 41. So PC square equals to 41. Then I copied the right triangle PAC in the new page and implemented the Pythagoras theorem on this right triangle, triangle PAC. This is the right triangle, triangle PAC that I copied from the original drawing. P equals to 6 units according to what is given us in the question. We define the length of AC as A, and we already found out that PC square equals to 41. So here by PT is a relation from Pythagoras theorem, and this right triangle PAC, according to the Pythagoras theorem, PC square equals to PA square plus AC square. PC square is 41, so 41 equals to PA square. PA is 6, therefore PA square is 6 squared, that is 36, plus AC square. AC is 8, therefore AC square is 8 squared. So we found out that 41 equals to 36 plus a squared. Here we subtracted 46 from this equation and finally found out that a squared equals to 41 plus 36, that is 5. Here we do go over this equation and finally found out that a equals to the square root of 5. Okay, so here a equals to the square root of 5. AC is equal to A. AC is equal to A, it is equal to the square root of 5 units. What is the length? First of all, we know that this is a semicircle, therefore AB is the diameter. So if we define the radius of this semicircle as x, then the diameter AB must be equal to 2x. So AB equals to 2x. It again, AB is the diameter. If the radius is x, then the diameter AB must be equal to 2x. What is the length of CB? From the drawing it is very easy to see that CB equals to AB minus AC. Repeat again. CB equals to AB minus AC. That is to say CB equals to AB, that is 2x. It is the diameter of the semicircle minus AC. AC is A and A is the square root of 5. So AC is 1 square root of 5. Okay, so in conclusion, found out that CB equals to 2x minus square root of 5. If CB equals to 2x minus square root of 5. Then we completed the semicircle to a circle. Then we extended side QC by a straight line until it touches the circle. We define the touching point of the extended QC with this circle as M. And then I presented to you rule number 11, and we implemented rule number 11 in our drawing. Okay, so according to rule number 11, in any circle, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times BO equals to CO times 0. According to rule number 11, if we have two chords that intersect with each other, then the following equation is true, that AO times OB equals to CO times OD. So we can actually implement rule number 11 in our drawing. Why? Because in our drawing we have chord AB that intersects with chord QM at point C. I'll repeat again. Chord AB intersects with chord QM at point C. Therefore, according to rule number 11, we get that AC times CB equals to QC times CM. Repeat again. According to rule number 11, AC times CB equals to QC times CM. Okay. AC is equal to 5, and CB is 2x minus square root of 5. Repeat again. AC is equal to 5 and CB is 2x minus square root of 5, and it is equal to QC. QC is 5, and according to our definition, CM is B. CM is B. Repeat again, QC is 5 and CM is B. So conclusion found out that according to equation number 1, square root of 5 times 2x minus 5 equals to 5b. Here we divided this equation number 1 by square root of 5, and finally we found out that 2x times minus square root of 5 equals to 5b over square root of 5. Then we added square root of 5 to this equation, and finally found out that according to this equation number 1, 2x equals to 5b over square root of 5 plus square root of 5. Then we multiplied square root of 5 by square root of 5, and then we divided it by square root of 5 in order to come out of this expression. And finally we found out that according to equation number 1, x equals to 5b over square root of 5, and then we multiply square root of 5 by 5, and then we divide it by square root of 5. So in conclusion we found out, then we divided this equation by 2, and finally we found out that x equals to 5b plus square root of 5 times square root of 5 is 5, so it is 5b plus 5 over 2, because we divided this equation by 2, so it will, in the numerator we have 2 times square root of 5. So in conclusion, x equals to 5b plus 5 over 2 times square root of 5. Then we joined points M and S together by straight line. So here we have peripheral angle MQS that is equal to 90 degrees. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Therefore, MS must be equal to the diameter of the circle. And repeat again, rule number 5. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here we have peripheral angle MAN that is equal to 90 degrees. Therefore, this peripheral angle must rest on the diameter of the circle. That is to say, MN is the diameter of the circle. We can implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle MQS that is equal to 90 degrees. Therefore, this peripheral angle MQS must rest on the diameter of the circle. That is to say, MS is the diameter of the circle. Because of the fact that peripheral angle MQS equals to 90 degrees, therefore this peripheral angle MQS must rest on the diameter of the circle. That is to say, MS is the diameter of the circle. and the radius is x, therefore the diameter SM must be equal to 2x. Okay. So the diameter MS equals to 2x, QS equals to 5 units, and QM in total equals to 5 plus B. So I copied the right triangle QSM in a new page and implemented the Pythagoras theorem in this right triangle, triangle QMS. This is the right triangle QMS that I copied from the original drawing, and repeat again that QM equals to 5 plus B, QS equals to 5, and the hypotenuse SM equals to 2x, that is the diameter of the circle. According to the Pythagoras theorem, in this right triangle, triangle QSM, SM square equals to QS square plus QM square. SM is 2x, therefore SM square is 2x square, and it must be equal to QS square. QS is 5, therefore QS square is 5 squared, that is 25, plus QM square. QM is 5 plus B, therefore QM square is 5 plus B square. This is equation number 1. Equation number 2. While according to equation number 1, so here we have, according to equation number 2, we found out that 2x squared equals to 25 plus 5 plus b squared. This is according to equation number 1. While according to equation number 2, we actually found out that this is according to equation number 2, 2x squared equals to 25 plus 5 plus b squared. While according to equation number 1, we have already found out that x equals to, well, according to equation number 1, we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So we can substitute x in this equation, equation number 2, by 5b plus 5 over 2 times square root of 5, because x equals to 5b plus 5 over 2 times square root of 5. Okay? So, we actually did it. So according to equation number 2, 2x squared equals to 25 plus 5 plus b squared. So 2 times x, and x is 5b plus 5 over 2 times square root of 5 squared. Is equals to 25 plus 5 plus b squared according to equation number 2. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we left only with 5b plus 5 squared over square root of 5 squared, that is 5. Here we have 25 plus 5 plus b squared is 5 squared, that is 25, plus b squared plus 2 times 5b is 10b. We open the brackets here and we found out that 5b plus 5 squared is 5b squared, that is 25b squared, plus 5 squared, that is 25, plus 2 times 5b is 10b, plus times 5 is 50b. All divided by 5, it is equals to 25 plus 25 is 50, plus b squared plus 10b. So here we have 25b squared over 5 is 5b squared, 25 over 5 is 5, and 50b over 5 is 10b, and it is equals to 10b plus b squared plus 50. So here we have 10b on both sides of the equation, so 10b will get cancelled. So in this side of the equation we left only with 5b squared plus 5. In the other side of the equation we left with 50 plus b squared. So here we subtracted b squared from this equation, equation number 2. So 5b squared minus b squared is 4b squared, so 4b squared equals to 45. Here we divided this equation, equation number 2, by 4, and finally found out that b squared equals to 45 over 4. Okay. Then we substitute 45 by 9 times 5. So b squared equals to 45, that is 9 times 5 over 4. Then we took out of this equation and finally found out that b equals to the square root of 9 times 5 over 4. The square root of 9 is 3 and the square root of 4 is 2. Inside the root we left only with 5. So in conclusion we found out that b equals to 3 times square root of 5 over 2. This is according to equation number 2, but according to equation number 1 we have already found out that x equals to 5b plus 5 over 2 times square root of 5. So we substitute b, this equation number 1, by 3 times square root of 5 over 2. And we got that according to equation number 1, x equals to 5b, and b is 3 times square root of 5 over 2 plus 5 over 2 times square root of 5. Here 5 times 3 is 15, so this expression in total equals to 15 times square root of 5 over 2 plus 5 over 2 times square root of 5. Then we multiplied 5 by 2 and then we divided by 2 in order to overcome factor with this expression. So 5 times 2 is 10 and then we divided by 2. So in total we found out that x equals to 15 times square root of 5 over 2 plus 10, all divided by 2 times square root of 5. Then we moved 2 times square root of 5 to the denominator and we finally found out that x equals to 15 times square root of 5 plus 10 over 2 times square root of 5. Then we took square root of 5 as a common factor from the numerator. So what is left from 15 times square root of 5 after we took from it square root of 5 as a common factor? What is left is actually 15. And what is left from 10 after we took from it square root of 5 as a common factor? What is left is actually 2 times square root of 5. Why? Because 2 times square root of 5 times square root of 5 is 10. All divided by 2 times 2 times square root of 5, that is 2 times 2 is 4, so it is 4 times square root of 5. Here we have square root of 5 in the numerator and we have square root of 5 in the denominator. So square root of 5 will get cancelled, and finally we found out that x, that is the radius of the semicircle and also the radius of the circle, x equals to either 15 plus 2 times square root of 5 over 4 square units. On terms of numbers, the radius of the semicircle x equals to 4.8680 units. Repeat again, the radius x of the semicircle equals to either 15 plus 2 times square root of 5 over 4 square units, or in terms of numbers, x equals to 4.8680 units. Okay, thank you very much.